Section 5.2 is adding and subtracting like fractions. I can add and subtract like fractions. So that's our learning target and what we're shooting for. To add or subtract fractions with the same denominator, we write the sum or difference of the numerators over that common denominator. So here are some examples. 4 over 9 plus 1 over 9. We keep the denominator as 9 and take the 4 plus 1 to get the 5. Works the same way with subtraction. 9/11ths minus 2/11ths. We keep our denominator as 11 and take the 9 minus 2 to get the 7. And it works the same there with our variables algebraically. So in example 1, it wants us to find the sum of 77 over 100 and 9 over 100. So sum means we are going to add. So I'm going to take 77 over 100 plus 9 over 100. And when I do that, since my denominators are both 100, I keep my denominator as 100 and go ahead and add my numerators. So I take 77 plus 9. This is going to give me 86 over 100. And we want to check and see if we can reduce. So here between 86 and 100, my greatest common factor is 2. So I can go ahead and divide by 2. And if you're not sure what the greatest common factor is, guys, find any common factor. You can break it down in pieces. So we can divide by 2, and then by 3, and then by 7, if those happen to be factors. So if you don't have the greatest common factor, it's not the end of the world. You're just going to have to do it in more than one step. In example 2 here, we're going to subtract our two fractions. So remember, when we have subtraction, we change to adding the opposite. So what I really have here is negative 4 over 7 plus negative 2 over 7. I have a common denominator of 7, so I keep my denominator as 7, and then I can perform my operations on my numerators. I can take negative 4 plus negative 2. Same signs mean I find the sum and give that common sign. So I get negative 6 over 7, and there is no greatest common factor other than 1, so we cannot reduce there. In B, again we have subtraction, so I'm going to change to adding the opposite. So what I really have here is 1/10 plus 3/10. I have a common denominator, so I keep my denominator here and perform the operations on my numerator. 1 plus 3. This is going to give me 4 over 10. We check for a greatest common factor here. I can take a 2 out of each. So I get 2 over 5 in simplified form. Here in number 1, we have a common denominator and we're adding. So I go ahead and keep that denominator and I can perform the operations on my numerator. So 3 plus 2. 3 plus 2 is 5, and I keep that denominator as an 8. 5 and 8 are relatively prime, meaning their greatest common factor is 1, and I cannot reduce them any further. For 2, again, we're adding, and I have common denominators. Since they're both 6, I keep my denominator as a 6 and perform the operation in my numerator. I'm going to take that negative with my 1 plus 5. Different signs means I subtract, give the sign of the bigger number, so it's a positive 4 over 6, and then we check, can we reduce? Well, I can take a 2 out of each of them as the greatest common factor, and I'm left with 2 over 3. On 3 here I am subtracting. Doesn't matter. For 3, we are subtracting. I'm going to change from subtracting to adding and take the opposite of the number that follows. Right now it's a positive 7 over 15, so I'm going to make it a negative 7 over 15. So I have 2/15 plus negative 7/15. I have a common denominator, so I'm going to go ahead and keep that denominator, and I can perform the operations on my numerator. 2 plus negative 7. We have different signs here, so we subtract, give the sign of that bigger number, and it stays over 15. Last thing we want to do is check to see if we can reduce it all. Here my greatest common factor is a 5, so I'm going to divide both top and bottom. Again, if we change one part, we have to change the whole thing. And I end up with negative 1 over 3, negative 1/3. In 4, I have subtraction. I'm going to change to adding the opposite. So what I really have here is 1/12 plus 7/12. Because I have a common denominator, I can keep that denominator and perform the operations on my numerators. 1 plus 7. This is going to give me 8 over 12. We check for a common denominator. For a greatest common factor. Here, between 8 and 12, my greatest common factor is a 4, which gives me a 2 over 3. Keep in mind, we could have, if we didn't recognize that our greatest common factor was a 4, we could have taken a 2 out first, so we'd have had 4 over 6, and then saw that we had something else that could come out. We could take out that last 2, and we could have gotten to the 2/3. So you could have done a 2 and then a 2 and still gotten to the same spot. In example 3, we're going to add and subtract mixed numbers. Here I'm going to treat these as two separate things for now. I'm going to take my whole number parts, 5 and 2, and I'm going to add them, which gives me 7. Then I'm going to take my fraction parts, 5 over 9, and 7 over 9, and I'm going to add them. Because I have a common denominator, I keep that denominator, and I perform the operations on my numerator. This is going to give me 12 over 9. I can reduce that by taking a 3 out of both, and it's going to give me 4 over 3. That is an improper fraction because 4 is more than 3. So I'm going to take 4 divided by 3, goes in there one time, and when we're trying to write these as fractions, our remainder is our numerator. What we divide it by is our denominator. So 4/3 is the same as 1 and 1/3. We also have this 7. So now 7 plus 1 gives me 8 and 1/3. So that's how it works if we keep our whole numbers and our fractions separate. The other way that we can do this is to convert to improper fractions. So in B, I'm subtracting. I'm going to change to adding the opposite. So here I'm going to have negative 10 and 6/13 plus negative 6 and 8 over 13. I'm going to switch both of these to be improper fractions. So I'm going to keep my negative for each of them. I'm going to take 13 times 10 plus 6 over my denominator. Here, since I already have my negative there, and we are adding, I'm going to take 13 times 6 plus 8 over that common denominator. This is going to give me negative 136 over 13 plus negative 86 over 13. Same denominator here, common denominator. So I keep my denominator as a 13, and I perform my operations on my numerator. So negative 136 plus negative 86. My numbers have the same sign, so I'm going to go ahead and add them up, which gives me 222. Since they're both negative, my answer is negative over 13. We don't want to leave our answer, though, as an improper fraction. So we're going to write this as a mixed number. In order to do that, we have to divide. We know it's going to be negative. So I take 222 divided by 13. 13 goes into 22 one time, which is 13. We subtract, bring down my 2, and here I get 9, so 92. 13 goes into 92 7 times. 7 times 13 is 91. I subtract, and I have a remainder of 1. So 1 over 13, and like I said, we know it's negative. So our final answer is going to be negative 17 and 1/13. So again, we can either treat these whole numbers as one thing, fractions as another, and then combine them at the end. Or we can switch to improper fractions and then convert back to mixed number at the end. Doesn't matter, whichever one you prefer. Just keep in mind that, especially when we're subtracting or we have negative numbers, sometimes it's hard to remember what to do with our values. In which case, especially when we're trying to put them back together with mixed numbers or with whole numbers and fractions. So sometimes it's helpful to keep them as mixed numbers. Keep them as improper fractions and then turn them back into mixed numbers. On 5, go ahead and find the sum or difference. Here, because we're adding, we're finding the sum. I'm going to go ahead and flip these into improper fractions. So 4 times 2 plus 3 over 4, which gives me 11 over 4, plus 4 times 1 plus 3. 4 times 1 plus 3 over 4 gives me 7 over 4. So my first step, switch to improper fractions. We have a common denominator of a 4 here, so I go ahead and keep it a 4. And then I can add my numerators. This is going to give me 18 over 4. Check to see if it reduces. I can take a 2 out of each, which gives me 9 over 2. Now we can switch that to be a mixed number again, because 9 is greater than 2. So 9 divided by 2. 2 goes into 9 4 times, which is 8. We'll subtract there with a remainder of 1. So 4 and 1 over 2 is what we get there. Give 6 a try. Here, I'm going to go ahead and switch to improper fractions. 3 times 6 plus 2 gives me 20 over 3. And then don't forget to make that negative. Plus 3 times 3 plus 1 gives me 10 over 3. Now that I have a common denominator, I can go ahead and keep my denominator, add my numerators. It's going to give me negative 10. Different signs we subtract, give the sign of the bigger number. 10 is bigger than 3, so we can go ahead and divide to switch it back into a mixed number. 3 goes into 10 3 times. 3 times 3 is 9, with a remainder of 1. So we get negative 3 and 1 over 3. And I'll finish up in another video.